Welcome and thank you all for standing by. At this time, all participants will be in a listen-only mode for the duration of today's presentation. Today's conference is being recorded. If you have any objections, you may disconnect at this time. I would now like to turn the conference over to Mr. Michael Hawes. Sir, you may begin.
Thank you very much, operator. And good afternoon, everyone, or good morning to those farther west. And welcome to our latest webinar on understanding the 2020 Census Disclosure Avoidance System. I want to start by issuing our apologies for the late start today. There is a major thunderstorm system rolling through the DC area, and it was affecting some of our internet connections and power. So thank you for bearing with us, and we appreciate your patience. Today's webinar is going to be about the production settings that have been determined for the production run of the Public Law 94-171 redistricting data summary file for the 2020 census. And we'll be discussing how we arrived at those production settings, and then we'll be examining some of the accuracy metrics that we've generated using those production settings in our disclosure avoidance system against 2010 census data to give you an idea of what the anticipated fitness for use and overall accuracy of the redistricting data product will be. Today, we're joined by Matthew Spence, who will be going through those accuracy measures. And we also have Jennifer Shopcorn, Megan Mowry, and Michelle Hedrick on the line as well. They will be helping us moderate questions. So during today's presentation, if you have questions for any of the panelists, please just type those into the Q&A feature in the WebEx platform. And please select all panelists when you're sending those. And that way we can all see those, and we'll try to respond to many of those questions in real time during the presentation. And then we'll provide answers for the remainder after the presentation is over. Before we start, I just want to give acknowledgments to the many Census Bureau employees who have contributed to the information that's included in today's presentation, as well as the collaboration from our many external partners. And I really want to provide a special thank you to all of our data users that have been providing feedback over the last couple of years on the various sets of demonstration data and on our various updates about the disclosure avoidance system. Not have made the improvements and the tunings that we have without that feedback, and it has been truly invaluable for us. Any viewpoints that are expressed today are entirely the presenter's own and do not represent the viewpoints of the U.S. Census Bureau. So on June 9th of this year, so just a little under a month ago, the Census Bureau announced that our Data Stewardship Executive Policy Committee had selected the final settings and parameters for the disclosure avoidance system run for the 2020 census redistricting data. The details of that have been included in a newsletter that we recently released, but we'll hit some of the highlights today. When making their decisions about the final system parameters, the Data Stewardship Executive Policy Committee evaluated a number of factors. They looked at the overall level of privacy protection that those settings would provide. They looked at our legal obligations under Title 13, Section 9 to protect respondent confidentiality. They looked at internal uses of census data, so ensuring fitness for use for those internal uses of census data, but most especially and most importantly amongst those, we evaluated the substantial amount of feedback that we received on the April 2021 demonstration data product. Now, we received feedback from a wide array of data users representing a very diverse set of use cases, but there were a number of common themes that we heard across many of the analyses and feedback that had been submitted to us. Those major themes that we heard in that stakeholder feedback included concerns about accuracy for American Indian and Alaskan Native tribal areas and other geographic entities that fall off of the central post-processing geographic hierarchy that our top-down algorithm uses. And we've discussed that geographic hierarchy in prior webinars. So if you want to learn more about that hierarchy, I suggest checking out our prior webinars, and there'll be a link at the end of today's presentation. So there was concern about accuracy for those off-spine geographies. There was also concern regarding accuracy for places, minor civil divisions, and particularly tract level statistics. Several of the analyses pointed out some lingering sources of bias that were occurring in the post-processing, particularly bias by geographic area and bias based on characteristics and particularly diversity. There was an overall concern for the accuracy of statistics about race and ethnicity, so Hispanic or not Hispanic. And then there was a recurring concern over the accuracy of occupancy rates at various levels of geography. So DCEP evaluated these various sets of analyses and feedback that we've received, and those factored very prominently in their decision-making about additional tuning of the algorithm and are reflected in the production settings that were selected and approved. Key parameters and improvements that are reflected in these production settings include a significant increase in the overall privacy loss budget for the 2020 census redistricting file. The privacy loss budget, or PLB, that was approved for the production settings includes an epsilon of 17.14 for the persons level file and an epsilon of 2.47 for the units file. And these are substantially higher than the privacy loss budgets used for the April 2021 demonstration data, which had an epsilon of 10.3 for the persons file and an epsilon of 1.9 for the units file. So these selections of privacy loss budget represent a significant increase in overall accuracy of the resulting data. Other key improvements that are reflected in these production settings are significant improvements to the optimized geographic post-processing hierarchy, which I mentioned, specifically targeted to improve accuracy for those geographies that are off of the central processing spine. Significant extra privacy loss budget has been allocated to population counts at a variety of geographic levels. Additional privacy loss budget was allocated to race and ethnicity statistics at a variety of geographic levels. And additional privacy loss budget was allocated to occupancy rates at the block group level and above. Now, if you want to understand kind of the full implications of these parameters, we did just publish earlier today the full set of privacy loss budget allocations for the persons file and the units file for both the U.S. and for Puerto Rico on our website, and you can find that on this link here. But I do want to highlight just a few of those and to explain how to interpret that privacy loss budget allocation table if you choose to review it. So the first is, and we've discussed this in previous webinars, the disclosure avoidance system's top-down algorithm allocates shares of privacy loss budget by geographic level and by query. So the amount of privacy loss budget that's assigned to any particular statistic is going to be the product of how much is assigned to that statistic's geographic level and how much is assigned to the particular query or queries that support that statistic. So looking at the allocation of privacy loss budget by geographic level, you can see some notable differences from how those privacy loss budgets were allocated in the April 2021 demonstration data. So on the left-hand side here, you can see at the top, that's the global rho and the global epsilon. Those are the overall quantities of privacy loss budget that are assigned to the persons file. The delta is 10 to the minus 10. That's a factor for interpreting the confidence of that privacy loss budget overall, and we can discuss that more in the Q&A if you like. But then underneath that, you can see how the privacy loss budget, represented here by rho, is allocated by geographic level. And you'll see those represented as fractions. So those are each a share of the overall privacy loss budget. And those shares all total to 1. And so you can see in the April 2021 demonstration data, there was substantially more privacy loss budget being allocated to the lower levels of geography, particularly block group and block. In the production settings, the production settings that were approved by DCEP, you will see, as I mentioned, a significant increase in the overall level of privacy loss budget. And remember, epsilon is on a logarithmic scale, so this is a substantial increase in overall privacy loss budget, which means that all of the statistics will benefit from improved accuracy. But then you can see that we made some notable changes in how that privacy loss budget is allocated over the different geographic levels. with particular additions of privacy loss budget being made at the state, county, tract, and optimized block group levels. So those represent some significant changes, and you'll see the impact of those in a few moments. Then we also were allocating privacy loss budget by the individual queries that support the production of the resulting data. And so here you can see the different sets of queries that we're making, tabulating off of the confidential data, and then producing the noisy measurements that are then converted back into the microdata that are tabulated for publication. And so you can see on the left, you've got the different sets of 11 queries that are used by the algorithm in its current design, and the fractions of privacy loss budget that are assigned to each of those queries at each geographic level. Looking on the right, you can see how those percentages, how those fractions differed in the resulting production settings that were approved by the Data Stewardship Executive Policy Committee. Key differences here that are worth noting are the additions of privacy loss budget, the greater shares of privacy loss budget that are allocated to the total population query, the total number of people at the state, county, tract levels. And then in particular, the increase in allocation of privacy loss budget for the Hispanic by race query. So all 63 OMB race categories crossed with Hispanic or not Hispanic at the U.S., state, county, tract, and optimized block group levels. So those changes in allocation represent a significant increase in how much privacy loss budget has been allocated to those particular statistics, above and beyond the overall increase in epsilon that the production settings reflect. And you'll see how that impacts accuracy in a moment, as my colleague Matthew Spence is going to walk through some of our detailed summary metrics for the production settings based on the 2010 census data and how they compare to previous demonstration data products that we've released. So Matt, I will turn things over to you.
Hello, everyone. Thank you for your patience today. I am the one, I think, most affected by these storms up in Silver Spring, Maryland. I actually don't have a camera on me, so I'm working on getting that restored, but in the meantime, I apologize for that. So I'm going to be walking through what we've been calling the detailed summary metrics that we use internally and we use for external audiences as well to assess the accuracy, the bias, and any outliers, how many outliers there are for these disclosure avoidance runs. So what these detailed summary metrics do is they compare tabulated quantities at various geographic levels for a DAS run to the published 2010 tabulations. So that makes it very easy for folks to sort of follow along at home and verify that our calculations were correct. So we'll look at, for example, total population at the county level, or we'll look at the count of persons who are Asian alone at the tract level, and we'll compute, various metrics that sort of address these three different topics. So the couple of metrics that we will be really focusing on are mean absolute error, or MAE, which is a measure of sort of what's the absolute average change. How many people on average does a particular geography gain or lose, as a result of the application of this disclosure avoidance method. We'll also be looking at something called MAPE, or MAPE, mean absolute percent error, which is a relative measure of that. That measures, sort of what's the average relative change. So let's go into, exactly what those are. Next slide, please. So here's an example of how we calculate the mean absolute error. We take all 3,143 counties that are stateside. We take the published 2010 population and we compare that to the privacy protected, that's gone through the DAS run. Here, these are being called the PPMF 2010 population. We get the error, or the noise, 10 people difference in Autauga County, Alabama, And, if it's a negative number, we take the absolute value, so Baldwin County has an absolute error of two persons. And then we take the average across all 3,143 counties for, an example. In this example, the mean absolute error is 4.91. So that means, you can see Loving County, Texas has a change of 5 people. That means that's, sort of an average amount of change looking at the mean absolute error. Next slide, please. We'll also be looking at the MAPE, or mean absolute percent error. The procedure is very similar. List out all of the counties in this case, and instead of calculating the difference, we calculate the percent error. So, the difference between Loving County 82 and, the privacy protected 77 is a change of 6%. So that's what we take the average of, and we get a mean absolute percent error in this example of 0.04%. So very small relative number. Next slide, please. So now I'm going to show you a series of graphics that kind of walks through the evolution of the disclosure avoidance system. One of the best parts about these metrics is that we can use them to compare the results across time and see the improvements that we've made as a result of the algorithms being tailored, the improvements to the geographies, as well as the increase in privacy loss budget. So what we see here along the horizontal axis is just, different demonstration products over time. The leftmost is October 2019. That was our first set of demonstration data products. And the most rightward one is the one that is the production settings run that we'll be discussing. That's what Michael was showing earlier, where was shown to the DCEP committee. That was the sort of exact same software that's used for the production run, but it's used on 2010 data so that we can go out and give folks and stakeholders a feeling about how accurate and what the fitness for use of these data are. On the vertical axis, we've got the mean absolute percent error, or MAPE. So this is a relative error term. So we can see that in October 2019, the average county gained or lost about 0.8%. That's not huge. That's not a huge number. But you can see that with the arrow, that translates to an average error of about 82 people. So the average county was gaining or losing about 82 people as a result of the disclosure avoidance run. Fast forward to the production settings, and you can see that now the mean absolute percent error is much smaller. It's about 0.02, I think, and you can see that translates to an average error of 1.75 persons. So the average county gains or loses about 1 or 2 people, on average. And so that's a significant improvement in the accuracy there. All right, next slide, please. So this is a measure of the county with the least populous counties, population under 1,000. One of the sort of initial bits of feedback we heard from stakeholders was that small areas or less populous areas were sort of disproportionately affected by this disclosure avoidance system. And you can see, in fact, in October 2019, the mean absolute percent error for these less populous counties was nearly 30%. It was well over 25%. So they were, on average, gaining or losing about a quarter of their population from the disclosure avoidance system, an average of 76 or 77 people. But due to various improvements, we can now see that under the production settings, that's much smaller. It's less than 1%, and it translates to about 1.3 people. So that's much better accuracy for these less populous areas. Next slide, please. Another area, so counties are sort of on the main geographic spine, and if you've followed along with our webinars, you've seen discussion of the so-called geographic spine, the sort of main geographies that make up the backbone census geographies. And counties are right on there. The place, these are incorporated places, and those are actually off-spine. These correspond to legal, sort of cities and towns, places that have, functional governments and the like that do not typically follow a tract boundary, do not typically follow a county boundary. They are considered off-spine. So one of the primary focuses of the last several rounds of the disclosure avoidance improvements has been focusing on these off-spine geographies to increase their accuracy and to make their data have a better fitness for use. So you can see that that's really paid dividends here. So we're looking at all 19,500 incorporated places across the U.S. And we can see that, in October 2019, the average error was over 10%. So the average, incorporated place was gaining or losing 85 people. And now that error is less than 1%. Or it's about 1%. So we can see that the average error is now 3.5 people. Which is obviously, much better, if you're a mayor trying to make planning decisions, if you're a city council trying to, make investments in schools. These are better, accuracy totals for that. So we're very happy with that. Next slide, please. Like we saw with counties, we are seeing a tremendous improvement in the accuracy for the least populous incorporated places. These are places with a population of under 500 people. And you can see that, whereas before in October 2019, the mean absolute percent error was nearly 20%, it is now closer to about 2%. So, this is a large proportion of incorporated places are these, less populous incorporated places. They do make up the sort of modal category for incorporated places across the country. And so it's great to see, increased accuracy for them. Next slide, please. So now I'm going to sort of shift a little bit to looking at mean absolute error. So rather than looking at mean absolute percent error, which is that relative error metric, we're going to keep it in terms of absolute number of persons. And as Michael mentioned, one place where we heard feedback about the April PPMF, we heard a lot of feedback that tracks saw a fairly significant step backwards in terms of accuracy. And you can see that here in the graph. The November 2020 PPMF, had, a mean absolute error of approximately 5 or so. And the April PPMFs had a mean absolute error of, either over 40 or over 20. So those are, obviously much less accurate when you're at the tract level. And you can see for the production settings, due to an increase in the row that is being allocated to that geographic level and just some additional improvements, that the mean absolute error now is much lower for the tract level. Next slide, please. Another area that Michael mentioned that we had lots of feedback for was about American Indian areas, American Indian Alaska Native areas, AIAN areas. So this is looking at federal American Indian reservations and off-reservation trust lands. Once again, we're still looking at total population, and we're looking at the mean absolute error. So you can see that between November and April, there's a bit of a step backwards in terms of the mean absolute error. There's a bit of a step backwards in terms of accuracy. But, again, due to the tuning that was done, we've seen a significant step forward in the accuracy for these areas for total population. It's now about 2. So the average federal AIR tends to gain or lose about 2 people. Next slide, please. And, yet another area that we sort of were examining was areas called minor civil divisions. For folks outside of the upper Midwest and Northeast, minor civil divisions are a form of government that sort of correspond to cities and towns for certain states. There are certain states that enact these county subdivisions as functional legal governments. So we really wanted to get additional accuracy there. So you can see that, between November and the production run, we've gotten additional accuracy. We've gone from about 17 to about 3 in terms of mean absolute error. So much better accuracy there. Next slide, please. So now let's take a look at characteristics. I'm going to sort of continue looking at mean absolute error. So these are, sorts of metrics of counts of persons, the average, difference that you expect to see in terms of raw number of persons. And I've just changed it a little bit here. So now the bars are going left to right instead of up and down. This is looking at voting age population at various geographies. So we've got county in the upper left, place, incorporated places in the top middle, and then federal American Indian reservations and off-reservation trust lands in the upper right, and then tracts and minor civil divisions on the lower level. For each, I put the average population of the various geographies just to kind of capture sort of what the sort of base population is. So, for example, for county, you can see the average population is 74,631. That means that the average number of people who are voting age in a county are about 74,000 people. Versus for a tract, lower left, you can see the average population is about 3,200 people who are voting age. So that kind of gives you an overall sense of the scale when you're comparing mean absolute error back to the overall population. The mean absolute error is the number that goes sort of along the horizontal axis, and it goes between about 0 to 35 on the rightmost side. All of these are on the same scale. And so, the takeaway from here is that there's been, additional accuracy, across the board for these various geographies for voting age population. You can see, in particular, we're seeing additional accuracy for MCDs, for tracts, and for federal American Indian reservations. So that was very nice to see. Next slide, please. Now let's look at race alone at the county level. So this is, looking at, how many people are, for example, white alone at the county level. That's the top left. How many people are black alone? That's just one to the right along the top row still. We've got AIAN alone and Asian alone to round out the top row. We've got Native Hawaiian Pacific Islander alone, some other race alone, and then 2 or more races on the bottom row. And, once again, we've got the various runs since November along the, sort of vertical axis, and we've got the mean absolute error along the horizontal axis. And here it goes from 0 to about 40 from left to right. Once again, I put the average population size along with each graph's title. So the average number of persons who are white alone at the county level is 71,127. And for the Native Hawaiian Pacific Islander alone population, it's 172. So that's, one of those reasons why, we have a very, different population. Some populations very large at the county level and some not. And what we can see is that, one of the bits of feedback that we heard consistently from stakeholders was that the race data at the county level looked really good. So we were really happy to see that, race data at the county level looked really good. And so that's why you'll see the production settings accuracy are very close to the April 2021 Epsilon 12.2 accuracy. So, that you can see that, pretty much across the board, they're nearly the same. There's actually even a slight bit of improvement for the 2 or more races population. Next slide, please. One area that we wanted to improve on, that we heard some stakeholder feedback from, and we actually even had internal stakeholders sort of asking for this additional accuracy, was race-alone populations at the tract level. So again, it's the same layout of the major race groups alone, and then 2 or more races on the bottom there. And you can see that, between April, even the April higher PLB, and in production settings, there's been a tremendous addition of accuracy. And now all of these are below 5 mean absolute error. So that's, that was the sort of threshold that was asked for to sort of get to that, plus or minus 5 on average at the tract level. So, that is very encouraging to see. Next slide, please. And likewise with county, we did not we got feedback that, the race data for the federal American Indian reservations and off-reservation trust lands were good, met the requirements for our data users. So that's why we don't see, we saw about the same level of accuracy for the production settings that we did for the higher PLB April release. Next slide, please. Another way to look at race, another way that demographers look at race, is to do race alone or in combination. So, for example, in the top left, white alone or in combination, that includes white and Asian, white and black and AIAN, etc. So it's race alone or in combination with one or more other races. And you can see that, as we heard from our stakeholders, the county level race data looked good in April. So the production settings were tuned to have similar levels of accuracy throughout. Next slide, please. Likewise, we heard that, by crossing race alone with Hispanic origin, to sort of get, Hispanic by selected race alone, we had heard that at the county level, the accuracy was good for the privacy loss budget, the higher privacy loss budget in April. So that's why you'll see, for example, Hispanic white alone is the top left. That's got a very close mean absolute error between the April 2021 12.2 and the production settings. The bottom left is non-Hispanic white alone. That, you can see, again, has about 20 mean absolute error, which is very similar to the April PPMF. And you can see it for Hispanic and non-Hispanic black alone, which is the middle column, and then Hispanic and non-Hispanic Asian alone, which is the right column. Very similar between the April and the production settings. Next slide, please. This just shows additional races, again, for the county crossed by Hispanic. So we've got Hispanic AIAN alone, and then non-Hispanic AIAN alone on the left column, Hispanic some other race, and not Hispanic some other race, and then Hispanic 2 or more races, and not Hispanic 2 or more races. And we did see, you could see that there is a bit of improvement for the 2 or more races, both for Hispanic 2 or more races and not Hispanic 2 or more races. Next slide, please. But as I mentioned before, at the tract level, we heard feedback that we wanted to see additional accuracy for these race groups, and that's why you'll see, much better accuracy, much increased accuracy for these tract level populations. These are the same groups that we saw on the prior 2 slides, but just at the tract level. And you can see that for all of them, they are now below 5 mean absolute error. Some of them were already below 5 mean absolute error in April, like, for example, the top right, Hispanic Asian alone. That's a very small population at the tract level. You can see the average population is 3. So it was already hitting that 5 number, but now all of the groups are hitting 5 mean absolute error or below. Next slide, please. And this is just a continuation. Even the 2 or more races, which are not specifically targeted in the query strategy, these are just sort of a method for combining races, that demographers use. But even though this wasn't directly targeted, that still inherited a great deal of accuracy at the tract level. Next slide, please. We implemented improvements along the way between October of 2019 and today for getting additional accuracy for group quarters. In particular, there have been some adjustments to how the geographic spine is created to try to isolate group quarters and get them to have additional accuracy. And you can see that in the data that we've had good levels of accuracy, for GQ by major type here at the county level. So you can see, for example, for the correctional institutions, which is the top left, the average population at the county is 720 people, and the mean absolute error is about 7. So your average county gains or loses about 7 people in correctional facilities. For lower left, college, another large major type of GQs, mean absolute error is about 5. So, good absolute error, mean absolute error there. The average county gaining or losing about 5 people in college dorms. Next slide, please. And we also saw additional accuracy at the tract. We know that we heard feedback that folks use group quarters data at lower geographic levels, such as the tract, and this demonstrates that we've been able to have good levels of error. There hasn't been any step backwards in terms of accuracy at the group quarters by major type level at the tract. Next slide, please. So one bit of feedback we heard really made us sit up and take notice, which was that there was a potential bias for total population for block groups and tracts based on the diversity of those geographies. So let's start at the top left table. What this is showing is that each row is a quintile in the diversity index. This is for the technical folks out there, this is a Blau index, but this is just a way of measuring racial diversity. And you can see that for the first row, the top row of data, the least diverse, most homogeneous block groups, they had an average difference in total population of 5, plus 5. And then for the most diverse, the bottom row of that table had a mean difference of minus 8. So that, and you can see that, as you go down the rows, it shifts from positive to negative. This was highlighted by several folks, Jan Vink, Todd Graham, and discovered internally as well by our demographers here. So that was obviously something that we were very concerned about. You can see likewise in the tracks in the lower left table in the April 2021 PPMF, we saw the same sort of bias, just even extended a higher magnitude. So the least diverse tracks were on average gaining about 16 people, and the most diverse tracks were on average losing 24 people. So that was something that we really wanted to address, and we were successful in our production settings. So the right column now, the top one is block groups, and the bottom right one is tracks for the production settings run. We were happy to say that these effects have been significantly attenuated or have gone entirely. This is due to some tuning that we did and some alterations to the query strategy to isolate total population in order to avoid that kind of covariance with racial diversity. So we're very, very happy to see that bias is no longer there, and that's something that we're going to continue to be looking into for production runs and in the future. Next slide, please. So with all this good news, what gains? What sort of where do we take any steps backwards? And so this is looking at block level mean absolute error, and what we can see is that between the higher PLB April PPMF and the production settings, there was a step backwards in terms of block level accuracy. This is just looking at urban blocks for now. We'll see a similar pattern for rural blocks in a second. But this sort of goes along with sort of the semantics of the top-down algorithm, that this helps to protect locational privacy for individual respondents. Blocks we know will be noisy, and in fact they'll be slightly noisier than we even saw in the April, the higher PLB April 2021 release. This will help protect locational privacy, and because we took a little bit of accuracy away from blocks, that allowed us to put a little bit more accuracy on block groups, tracks, counties, and other sort of geographies that we believe are more useful for data users. That said, all of these runs still meet the Department of Justice use case for the Voting Rights Act that has been discussed in prior webinars, where there's accuracy for the largest demographic group for small places, block groups, and AIAN areas. We're still meeting that threshold of fewer than 5% of these areas have a greater than 5 percentage point change in the relative share of the large demographic group. So that's a lot, but what this means is that we're still meeting that use case that we set out for in April 2021. Even though we took a little bit of accuracy away from blocks, we're still meeting that threshold. Next slide. And here we are for rural blocks. We can see that, once again, there's a bit of a step backwards in terms of accuracy at the block level for these rural blocks. But if you want to get a sense for about how, accurate they'll be, you can look at the lower PLB April 2021 release. It'll be about the same mean absolute error for total population at the block level. Next slide, please. This is my final slide, and this kind of goes back to our discussion that we've been having, which is that blocks will continue to be noisy. And in particular, blocks, the person-level data is being processed separately from the unit data for this release, for the PL release, and for the upcoming DHC release. These are two separate files, so if you try to compare between the two, you may get impossibilities, or probabilities, or inconsistencies between the two. So, what are some of these examples that we're talking about? So the first row is occupied housing units greater than household population. So we know that that's not, theoretically possible, because if you're an occupied housing unit, that means you have at least one household person in that unit. And if you have, for example, 10 occupied housing units and 5 household people, that implies that some occupied housing units are empty or have fractional people, and that's not a possible solution. But we do see that occurs, at the block level. So for the production settings, we saw that now there are about 303,000 blocks that have this sort of inconsistent result. Looking at the second row, I should say, there are about 505,000 blocks where there are 0 occupied housing units and, one or more people in a household population. So that is, obviously another inconsistency. Household people have to live somewhere, and they should live in an occupied housing unit. The converse is that third row, 0 household population and more than 0 occupied housing units. There are about 150,000 blocks that have that in the production settings. And then the second to last line is everyone in the block being under the age of 18. That happens in 163,000 blocks. This actually is only the person level data. This is not a result of the separate processing of the person and the unit level data, but it comes from the same place, which is just that blocks are noisy in themselves, and voting age and not voting age were not held invariant, and they were given at a very high level of privacy loss budget for these blocks. They're very small populations, and so just by virtue of them being small, you can occasionally have it so that there are no sort of people of voting age at a particular block. And then finally, I think an improbability. We don't typically see blocks with greater than 10 persons per household, but we do see it in the production settings. So what does all this mean? What this means is that blocks are noisy, and that we will see these sort of inconsistent results, particularly when you're looking between a person-level statistic and a unit-level statistic. But there are 2 ways to sort of address that. Number one is that by the time you get to block groups, if you start to count the number of block groups that have these inconsistencies, it goes way down. We're talking a handful of block groups, a handful of tracks have inconsistencies like this. So the number one piece of advice is to just realize that blocks are noisy, and that tracks and block groups are much less noisy. They may occasionally still have inconsistencies like this, but those are going to tend to be very, very small tracks or block groups. And then the second thing to note is that the Census Bureau is planning a data release later. We don't have a specified date yet, but we're planning a release that will specifically bring the two of these files, person and unit, together. It's called the person housing unit joins, and that will provide differential private, run through a similar algorithm, but it will provide data on persons per household that folks can use that will not have these kinds of inconsistencies from two different files being added with two different bits of random noise. So that is in the works. So if you really need persons per household data, stay tuned for the detailed demographic and housing characteristics, or detailed DHC, which is forthcoming. So all in all, we were very happy to see a lot of feedback from our stakeholders. We read every single note and reported them to senior management. Senior management took it very seriously, the bias findings, some of the accuracy findings, and responded by additional tuning of the disclosure avoidance system and additional privacy loss budget to really guarantee accuracy to ensure a good fitness for use for data users for the 2020 census. So with that, I'll hand it back to you, Michael.
Thank you so much, Matt. So for those who would like to stay informed on our updates to the disclosure avoidance system and subsequent data releases, data products, etc., you can subscribe to our 2020 Census Data Products newsletter. Just go to census.gov and search disclosure avoidance. That's where you can always stay up to date on all the latest information that we have. You can also visit our website. We have a wide repository of useful information there, including all of our past newsletters, all of our demonstration data, detailed summary metrics. We've got frequently asked questions, white papers, and just a lot of really helpful information for understanding our decisions for modernizing disclosure avoidance for the 2020 census and how we're implementing that. And I do want to give a kind of late-breaking preview here. We have a new video up on our website, just got posted today, on protecting privacy in Census Bureau statistics. This is a great video that's really useful for particularly helping people who have not been following along very closely with our updated methodologies, and kind of introduces the concept of differential privacy, why we're adopting it, and what it means for your use of data. So if you'd like to see our new video, definitely just go to census.gov, search disclosure avoidance, and it's right there. We think you'll really enjoy it. And so with that, I think we have about 6 minutes left for some additional questions. I know that Megan and Shelley and Jen have been answering some of your questions during the presentation, but I'm going to stop sharing my screen so that I can see some of those questions as well, and I'll turn things over to Megan and Shelley to help moderate some of those questions for you.
Thanks so much, Michael. I'm going to try to aggregate. There's a lot of questions in the Q&A, so I'm going to try to aggregate some of them together to hopefully answer, at least in general terms, a bunch of the questions at once. I think the first kind of theme I see in the Q&A is questions about what, why these metrics, why not other metrics? Can we see more metrics by, the size of places or the size of, block groups or tracks? The answer to all of that is yes, there is so much more. Shelley has put in the chat a link to the full detailed summary metrics. Obviously, we couldn't show them all here to you today, but we would love for you all to dive in, take a look at those. Matt, is there anything particularly you want to draw people's attention to in those detailed summary metrics?
I think the main takeaway for me was sort of what I showed for the least populous counties and the least populous places. These are, the least populous places in particular are, there are about 6,000 of them or more. I don't have it in front of me. My computer is still working on getting up. There are many thousands of these very small incorporated places. And if you look at the accuracy, you can see that the total population accuracy is very good, even for those very small, less populous incorporated places. And I imagine that, for various user-defined geographies, these accuracy at these small levels will sort of inform what you can expect for the accuracy for those. By adding up blocks into larger aggregations, you will get, sort of increased, accuracy by virtue of, being larger. And then by being closer to the spine, being closer to the geographic spine. So where possible, following tract lines or following block group lines will also, inherit accuracy for those larger geographies. And you can see that, with, you can see in the metrics, other off-spine geographies like school districts that may be of interest to sort of get a sense of like what's the average error for an off-spine geography.
Yeah, thank you. That's all great information. You actually kind of just answered another one of the themes of the questions in here. It seems like there's a few questions that ask things like, if blocks are noisy, does that mean block groups, because you're adding together a bunch of blocks, are super noisy? And as you just said in your answer, it's kind of the reverse of that. The block group is more accurate. It gets more accurate as we go up that geographic spine, by geographic spine, which is a totally technical term, I mean from block to block group, from block group to tract into those larger and larger geographies. Is that right? Am I misstating that, Michael?
No, absolutely, and that's a great point to make. That's one of the central features of the top-down algorithm, which we're using for the 2020 census, is that it's designed that, yes, the lowest level of data will be the noisiest, but that noise cancels out as you aggregate those pixels together. And if you want a more detailed explanation of how that happens and why the algorithm is able to ensure that pattern, definitely check out the previously recorded webinar that we did. I think it was a disclosure avoidance or differential privacy 201, the top-down algorithm, available on our website. That goes into the mechanics of how the algorithm works and how we're able to ensure that as you aggregate those noisy blocks together, you're getting reliable and valid results from those larger aggregations of blocks, whether it's to block group or to an off-spine geography like a census-designated place or a voting district, for example.
Great. And then there's a few sort of just clarifying questions I just want to throw out to you rapid fire. One is, are Oklahoma tribal statistical areas included in the metrics we showed for tribal geographies in this presentation? Matt, do you know that off the top of your head?
They were not included in the presentation that we just showed. We split out federal American Indian reservations and off-reservation trust lands separately. There are about 324 of those. We split those off separately from Alaska Native Village statistical areas and Oklahoma tribal statistical areas. Both of those are in detailed summary metrics. We actually go into a fair amount of detail for OTSAs and ANBSAs, as well as federal AIRs. So please do look at that spreadsheet and enjoy.
Great. And one more, I know we're running really out of time, but one more quick clarifying question. Someone in the Q&A asked sort of where the diversity index metric came from that we showed in the presentation here. I think you mentioned maybe it was proposed by one of our stakeholders in the review process. Is that right?
Yeah, that's correct. It was proposed by Columbia University professor Jan Vink. It is essentially 1 divided by the squared proportion of each different major race group. We are actually planning a supplemental release of metrics that will include this diversity index, metrics on this diversity index, looking at potential signs of bias by this diversity index, as well as sort of distributions of errors. We've heard some feedback from people that looking at the mean, looking at the average is nice, but what they really want to see are sort of more worst-case scenarios. We're working on getting that released as well as a supplemental release to the detailed summary metrics.
Great. Thank you so much. That's really interesting. There are a lot of questions in the chat that I know we've answered on prior webinars or through our newsletter, so I really encourage people, if you have you have a few minutes to go tune into those, we'd love for you to dig in even deeper on all of these details. And again, many of the questions in the Q&A address metrics that are included in that broader detailed summary metrics, even if we didn't include them in the presentation here today. So we do encourage you to check out that file. One last sort of set of questions, and then I promise Matt and Michael, I will let you go. Folks were just asking some questions about, is this algorithm that we announced the DSEP decisions about, is that the same algorithm that we'll use for later data products, or is that will we be doing a whole new thing for that?
So great question. So the top-down algorithm, which is what we were using for these runs that we were discussing today, and what will be used for the actual PL 94171 redistricting data product, will also be used for the demographic and housing characteristics file, the DHC, which is the next major product in the sequence of 2020 census publications. Now, it'll be the same algorithm, but it will be tuned specifically for the DHC. So much like we did a tuning over various PPMF runs of demonstration data for the PL file, and then additional tuning between the April demonstration data and the production settings. We'll be doing similar tuning for the DHC, where we're varying the allocation of privacy loss budget, the overall amount of privacy loss budget, specifically to ensure fitness for use for the various use cases that the DHC supports. So the top-down algorithm will be used for the PL file and the DHC. The subsequent data products after DHC, what are known as the detailed demographic and housing characteristics, will also be protected with differential privacy, but they're going to be using a different set of algorithms. And those are to address issues, particularly like Matt was mentioning about the person household joins for the household characteristics data, but also to produce the detailed race, detailed ethnicity, and the detailed American Indian, Alaska Native tribal data. So those will be processed with a separate set of algorithms than the top-down algorithm which we were looking at today. So top-down algorithm for PL and for DHC, different set of algorithms for the detailed DHC.
Thanks, Michael. And I know a lot of questions in here were about whether we would be doing stakeholder engagement for those later data products. Of course we will. We're excited to work with you on that. I will say there are dozens and dozens and dozens of questions in the Q&A. We do not have time to address them all today, but we do want to keep hearing from you, and we want to keep providing answers for you if and when we can. So if you have additional questions, feel free to reach out to us here at Census Bureau. Right on that same page where you found the detailed summary metrics, you can find more information, again, about the answers to a lot of the questions that you had here. But if you have continuing questions after taking a look at those materials, please reach out. We're happy to help you get what you need. Thank you so much, Michael and Matt, for sharing so much of your time with us today. Michael, I'll toss back to you to close us out.
Great, thank you. And again, I'll just reiterate, please check out our website. Take a look at the detailed summary metrics. It provides much, much more detail than we were able to go into today. If you have additional questions, please send those in to our website, to our email, 2020das@census.gov, and you can find that email address on the website. Thank you so much for joining us today, and we look forward to continuing to engage with all of you as we move towards the tuning for the demographic housing characteristics files. And with that, I will conclude today's webinar and turn things back over to our operator.
Thank you all for participating in today's conference. You may disconnect your line and enjoy the rest of your day.